Great. So yeah, again, thanks for making it today. Thanks for participating in this session. Let's get started with a few questions to the audience. Who of you believe that IT today is really agile enough? Just raise your hands. Who believes that IT today is actually cost efficient in connecting companies and building ecosystems? Still no.
Depends.
It depends, right. And so the next question, who believes that distributed ledgers could actually be a solution for that? Now, please raise your hands. Yes, actually, as you might guess, Deon Digital, the company that I work for, believes so. And we propose a technology to actually build cross-industry ecosystems, which in our view could become the successor, and I'm talking about the technology, not obviously about our company, the successor to today's ERP systems, which basically took down the silos within companies and integrated processes within companies. Before we get started, quick word about myself. Name is Samuel Meyer. I'm Chief Marketing Officer of Deon Digital, a young Swiss startup. We are now about 10 months old. Quite atypical for a startup. We have a technology that was developed over a period of 10 years, so there is a bit more behind the whole thing. We have a whole team of a professor and his PhDs in Copenhagen on board, so that gives us a bit of a depth compared to the age of our company, and we are basically based in Copenhagen, Munich, and Switzerland. So, again, the topic today, how to build cross-company and cross-industry ecosystems. And obviously, as you can guess, we believe part of the solution will be distributed ledger. But we have been asking ourselves whether that's going to be sufficient in order to create processes that span multiple entities. And our team and our company came to the conclusion that it's not sufficient actually to just propose a network, a distributed network of nodes and secure transactions in order to really create business contracts among parties, but there is actually a common language required. And so that's what the technology we do evolves about. And let's best get started with an example. I'm from Switzerland, as you might have heard already. So my expectation was obviously our first client would be a bank. No, it was not. It was actually Daimler, a mobility company. I did not have that much experience in mobility, so I was quite surprised myself. But in mobility, they have the problem since a while that cars producers, such as Daimler, actually know that or believe that in 10 to 20 years they will probably not be selling as many cars anymore as they do today. But what they will do is rather actually providing mobility to people who need a ride, let's say, from Zurich to somewhere around Berlin. And they have been trying, together with other companies, among else the Bundesverband Digitalwirtschaft, they have been trying to build such a platform. And they have started that initiative 5 to 10 years ago, but so far the initiative was not particularly successful because they were relying on traditional technology. And you all know traditional technology, the whole silos, the difficulties to build APIs from every company to every company in the network. And so, long story short, after even the lawyers got involved and wanted to clarify every potential contracting situation that could emerge, there came a point where the project was installed. And that's actually where we got involved. And quickly, 3 minutes on what Daimler now plans. Schon ist gut.
Man sieht das nicht.
Ja.
Our world is changing. Megacities are rapidly growing.
Ich glaube, das ist irgendwie mehr so ein Bildschirm.
Oh.
Our world is changing.
Okay.
Megacities are rapidly growing, up to 53% by 2025. By 2030, 60% of the world's population will live in dense urban areas, challenging the way we live, commute, and travel. Consumers demand seamless mobility that suits their lifestyle. Sharing is the new owning. Access is the new product. Hannah is ready to commute to work. Her mobility contract gives her access to multiple options. In the future, we expect mobility to be a holistic and connected service. Based on her needs, the right service is chosen. Hannah needs to prepare for a meeting, so she is taking a pool car. An intelligent system controls the carpool based on traffic, availability, and location. An autonomous, driverless vehicle enables distraction-free working, even on the go. Cars, objects, and services communicate with one another. 30 billion devices will be connected by 2030. Induction technology charges the car on the road. On arrival, a micropayment is automatically transferred to the car. The vision is beautiful, but it currently requires a complex network of businesses, services, and transactions. The current state is inefficient and full of friction, making it difficult to collaborate. The entry barrier for new businesses is high due to legacy issues, efforts, and costs. Introducing the Mobility Operating System. An open, collaborative standard digital environment created for mobility services running on the blockchain. The model environment is based on a domain-specific language, reducing the complexity of developing new applications. Improving stability through automated tests and validation. The API provides easy access to services and smart contracts. The API also lowers entry barriers and facilitates collaboration. A distributed ledger acts as a safe authority that enables users to reclaim their data and personalize their offering. Hannah's car could be charged automatically because a contract agreement was already in place. With each new service provider, the complexity grows. To create seamless experiences, we need to collaborate. The future of mobility demands standards and collaboration. MOS is the only technology specifically developed for our future mobility. We want you to join us. To define, to design, to decide. Our vision, to create an open consortium. Let's define the future of mobility together.
So while I switch back to the presentation, just to give you an idea of how disruptive Daimler is thinking here, they actually invited BMW to join their platform. So that they really mean business. Now on the
Is BMW joined?
It's still being discussed, but there is actually discussion with many companies now joining this consortium. So there is Lufthansa, Deutsche Bahn, a Dutch insurer. And let me explain a bit what the trick was that Daimler actually pulled off here to make this work. You see on the left side, you see a traditional technology to do this. And what you can see very quickly is that the whole complexity to connect every party with every party to then build a system top down, as we all know, traditional IT development, in order to basically build a mega model that can handle every potential contracting case, every potential mobility case, in order to then issue a ticket. Now the trick that Daimler pulled off is to get from Zurich to somewhere in the vicinity of Berlin, involving a train, a plane, a rental car, and an insurance for the whole package, was to say, instead of building a mega model and a mega system to handle every potential case, we just provide a platform, that's the middle layer that you can see on top of the distributed ledger. So let me say differently. First, obviously, we connect the parties via a distributed ledger network. We then build a platform where individual parties can add their mobility contracts. So SBB in Switzerland can actually add their train ticket, Lufthansa can add their airline ticket, Daimler can add their rental ticket, always in the form of a scripted contract. Achmea, the insurer, can add the wrapper for the insurance around this whole thing. And when a client then comes through one of the front ends, be it Daimler front end, be it Lufthansa front end, be it the SBB front end, the MOS will actually bundle the corresponding contracts into one package. So it will actually bundle the 4 contracts required and give it all back through the front end the client was accessing. Therefore, what you have created is not only a system that is open for new parties, this will all go into a foundation. Not only have you created a system where multiple parties can contribute contracts and do business together, but you have also created an open system because people can really contribute their own contracting versions. And what I will now explain a bit is how that works. The basic idea is that on top of distributed ledgers, which you again see on the left side, you need an operating system. And this operating system not only needs to have need to set some standard and have a classic runtime environment where contracts actually get executed, but it also needs a development environment where you can basically script contracts. I will explain now a bit more what scripting of contracts actually means. However, just to make a simple comparison, the same thing happens to the phones you're all using to take pictures or to send messages or whatever else. The phone is, for example, produced by Samsung. You might have an operating system by Android, and within this operating system there is an app store where people can actually have an environment to develop applications. And that just basically facilitates the process, makes it more efficient, reduces risks, and so on and so on. Now, let me explain a bit what I mean when I say scripting contracts, because obviously that's something that seems a bit strange of a concept, but that's really at the core of what we do. Scripting of a contract means that you basically have a language that allows you to describe a business relationship. In very simple terms, I agree with somebody that is connected to the same distributed ledger that I first deliver something and then, and only then, that I first pay something and only when I've paid, only then there will be a delivery of a certain good and only that good and only according to a certain timeline and so on and so on. In our environment, we actually script that contract in exactly that fashion. That such a contract, called the DVP contract, would roughly take you 12 lines of code in our language. I will show it afterwards, this code. And what our technology then does, it actually translates this code into a mathematical tree of potential future contract states. So basically our technology really evolves of putting contracts into mathematics, and by doing so we actually then create contracts that are represented as trees of potential future states that can be combined. And suddenly you start probably getting the idea how we can combine mobility contracts. You just add the tree for the plane ticket on top of or below the tree of the train ticket, and you then add the tree of the rental car below the tree of the flight ticket, and the whole thing then is added with the tree of the insurance contract. And this tree is then saved on the lowest level on the distributed ledger. Typically we work with private distributed ledger technologies because parties are identified when we talk about corporates. And as events happen on that ledger, the corresponding trees realized, hey, this concerns me, and get reduced. What do I mean by get reduced? It means for the DVP example that we made before, it means for the DVP example that we made before, that the contract that was stored on the ledger realizes that a payment was done, and there might have been 10 payments before, which were the wrong payments, but then when the right payments happened from the right party to the right party, with the right amount and within the right time, then that contract would realize, hey, the payment was done. The left side would get reduced, as we say, so it basically it falls away. And the remainder of the contract that is again saved on the ledger would actually just say, okay, now we wait for the delivery of the corresponding good. Now, this is obviously a very simplified example, but it shows that smart contracts are neither that, as we say, they're not particularly smart, not are they really automated, as a lot of people say. What they actually are is a representation of potential future states of a transaction, and this representation waits for events, and as events happen, they get reduced in order to basically show the current state of the transaction. Now, this little picture actually has two tremendous advantages that are not easily seen, but that are actually a game changer. One thing is that you should be all familiar with, as obviously every event is locked on the ledger, and all contract states are also saved on the ledger, you always have the full traceability to go into the past and do kind of a time warp function, for those who use apples, in order to go back in time, so to say. But also, since every contract that is stored on your system includes all potential future states of the contract, and as you might have a dozen or even hundreds or thousands of contracts, you can actually very easily simulate what your future business could look like. You just go through, you aggregate all these trees, you go through the potential states, you do a distribution of this, and basically assign probabilities to the different options, and what you have is basically a simulation, it's basically a risk modeling system directly out of your core system. No need for a separate risk modeling anymore, as we are all used to do today. Now, to make this even more specific, how would the code for this look like? Let me see whether I can actually zoom here. Yeah, that works. This is our language to describe the DVP payment, the DVP contract that I mentioned before. This is how you program in our environment. Who can read this? Who can read Java code?
Not so good.
Not so good, huh? And just to give you the comparison, this is, as I said, 12 lines if you take, or 11 lines even if you take the empty lines away. In Java, we programmed the same, and it was 6 pages. And we have good programmers in our company. Actually, most of the employees have PhDs in IT. They had 6 pages to program this, while with this language you had 11 lines. That probably kind of shows you the disruptive nature that this can have. This program code then by our technology gets translated into the corresponding tree. This is automatically generated. And this is the tree that then sits on the ledger and actually waits for events. And you can see that it waits for events because it automatically has identified here that in the next step there needs to be a payment for the bike contract that was done by Alice and with some conditions. And this is only one contract, but obviously in a productive environment you would have thousands, 10,000s of contracts at the same time, and for each and every one you would know, okay, what's expected in the next step. Now, what does that in turn mean? Not only that the development process will become much shorter, this is just the classical development timeline for IT systems, from conception over designs, implementation, testing to operation, you could say the classical V approach. So not only that gets disrupted when it comes to system development, because basically the business analyst can now script directly the application that he has in mind. One side note, we don't do front end. So the front end for systems would in the future either still have to be developed by separate companies, but you all know there is dozens of front end providers out there, or dynamically generated with a technology that you might add on top of our technology. Anyway, so the system development is greatly facilitated, but not only the system development is greatly facilitated, testing is completely changed. In the past, what we basically do when we say testing in IT context is we do sample tests. We say, what are the 80% most probable cases? We test through them, and if everything goes right, we assume that the system will work. But we'll never have 100% clarity that it really works that way. Now, with traditional IT, that was okay because there was always a user to check whether things work well and whether there wasn't an issue. But now imagine that you have more automation. You have contracts that execute themselves. And as we have seen with many, in the context of many ICOs, that is a real risk. If you have some bug somewhere, it can be a very small bug, but it might be sufficient to actually blow your whole business out of the sky. Now, since in the case of such technology, you have the modeling of all potential future states that the system may actually take inherently by the way it's scripted and programmed, you can actually just run a test to go through, called formal verification, to go through all potential future states. Now, we believe this is so much better that in long story short, it will define a new de facto standard. It's quicker, more agile, it's more cost efficient, it reduces risk as mentioned. So we believe this will actually set a new de facto standard. And just to leave you with food for thought, to go home, we also believe this will basically change the nature of human contracting. Because you add to this technology, as I mentioned before, the possibility to dynamically generate front ends, which our APIs basically provide you with the possibility to do so. You add to that autonomous design, so the ability for a computer to autonomously design something, like a bridge might be designed by a computer. And you add to this the potential for a computer to understand human language. And what you basically have is an IT system that builds itself. You sit there with a friend of yours, you discuss a potential business that you want together, you write it on a piece of paper, or the computer might even be listening. He understands what you have discussed, he understands the agreements you took, he formalizes that in the scripting language, he builds the system autonomously around it, because that's what our technology already today allows you to do, and the whole rest of the execution of your business, including the reporting, is autonomously done. That's, to speak in Elon Musk's terms, our trip to Mars. Thank you for your attention.